right, here's the second screencast for stoichiometry, objective number 3, calculating the molar mass of a compound. This is actually really easy to do, but you will need your periodic tables. So our essential question, how is molar mass calculated and what is it used for? You're going to see over the next couple of days what we use it for. So what is molar mass? Well, molar mass is the mass of 1 mole of atoms, elements, or compounds of any substance. So if I took 1 mole of oxygen atoms, which would be 6.022 times 10 to the 23rd oxygen atoms, how much would they weigh? That's the molar mass. If I had 1 mole of water molecules, how much would it weigh? That's the molar mass. So you're going to use the periodic table to calculate. The nice thing is you're going to use the masses on the periodic table. So you use the masses of each element times the number of atoms, and then you just add them all up. The molar mass for an element is the atomic mass that's on the periodic table. So for oxygen, it would be 15.9994. That's how many grams 1 mole would weigh. For hydrogen, 1.0079. So if I had 6.022 times 10 to the 23rd atoms of hydrogen, it would weigh 1.0079 grams on a scale. It doesn't weigh very much. That's a lot of atoms to not weigh very much. So that's the nice part, is the masses on the periodic table are essentially the molar masses for each one of those elements. Well, how do I find it for a compound? I take the mass of each element times the number of atoms, and then I just add them all up. So that's what I've shown you here for these 2 examples of water and calcium hydroxide. So water, I have 2 atoms of hydrogen and 1 atom of oxygen. So for the mass of hydrogen, I take 1.0079 times 2 equals 2.016. That's what my calculator gives me. So that's the mass of hydrogen that I have in this compound. The mass of oxygen atoms would be 15.9994. These numbers tell me how many moles I have. So I have 2 moles of hydrogen. I have 1 mole of oxygen. And then all I have to do is take the hydrogen and the oxygen and add them up. So 2.016 plus 15.9994 equals 18.02 grams per mole. So if I said, go weigh me out 1 mole of water molecules, which would be 6.022 times 10 to the 23rd water molecules, it would weigh 18.02 grams on a scale. This is relating chemical formulas and chemical reactions to actual masses that we can work with. This is now getting us to something that I can put on a scale and work with. Calcium hydroxide. I have 1 atom of calcium. Remember, the parentheses tell me that I have to distribute this too, so I have 2 oxygens and I have 2 hydrogens. So calcium is 40.08 grams, according to the periodic table. The mass of oxygen, I have 2 of them, so 2 times 15.9994, which equals 31.9988. And the mass of hydrogen equals, it should say 2 times 1.0079 grams, giving me 2.016 grams. So the mass on the periodic table times the number of atoms. There should be a 2 here, so 2 times that. There's only 1 calcium, which is why I only have one atom of calcium given. Add all the masses up, 40.08 plus 31.9988 plus 2.016 equals 74.09 grams per mole. So if I said, go weigh me out a mole of calcium hydroxide atoms, you could find the molar mass, and that's how much you would weigh out. If you needed 2 moles, you would just take this number times 2. If you needed 3 moles of calcium hydroxide, you would just take this number times 3. So this is definitely a way that we can relate the masses on the periodic table to grams, which is what we need to weigh them out on a scale to know how much to start with. Here are 4 more examples. We're going to do these 4 in class, but you can do them on your own. I suggest you do them to at least try it out, and then you can check your answers with us in class. We are going to do a molar mass handout as well, which are just some practice problems to complete. So the summary format for objective number 3 is a 20-word summary.